Tried and Blue, a play on the phrase tried and true, the Erland Tried and Blue blog and podcast covers past and current successes that prove how effective and reliable our construction management services are. Welcome to the Tried and Blue podcast. I'm your host, Nicole Harrison. Today I'll be talking with Michael Atwood from Haley Aldrich and Vernon Frier from Keller, North America, as well as 3 Erland team members on permeation grouting and how this approach was utilized at one of our current projects together. Erland Group Manager Ben McConchie will moderate, and Senior Project Manager Ted Nevells and Field Supervisor John Suttie will be joining in as well to discuss this unique process. But before we get started, Mike, Vern, Ben, Ted, and John, can you tell the listeners a little bit about yourself? Mike, you're up first.
Sure, thank you. Mike Atwood from Haley Aldrich. Haley Aldrich is a geotechnical and environmental firm in Boston, and I'm a principal with the company, and I was the principal consultant on the project that we're going to talk about today.
And Vern, go ahead.
Hey, everybody. My name is Vernon Frier. I'm a senior project manager with Keller and Keller Legacy Companies. I've been around this business for about 36 years. I'm originally from Saskatchewan, but live in Ontario, Canada now. Enjoy fishing, kayaking, snowmobiling, and not so much pushing snow around. I've had my dog Rex, who's a rescue. I've had him for about 4 years. That's about it.
Great. Thanks, Vern. And Ben, you're next.
Ben McConchie with Erland Construction. I'm a project executive on this project, as well as the group manager here at Erland for the academic, corporate, and commercial group. Outside of work, I enjoy kind of youth sports with my kids. Keep me pretty busy.
Ted, go ahead.
My name is Ted Nevells. I'm a senior project manager at Erland, working full-time on the site. I grew up in Maine, in a little fishing village up there. Went to college in Mass, was in the Navy for 7 years. Been married for 40 years. I have 3 children. My oldest daughter has 3 grandchildren who, unfortunately for us, live in San Diego, so we don't get to see them very often. I have 2 dogs. I have a rescue pit bull, and I have an English bulldog who keep us busy at this time.
We love all the dogs on this podcast. And last but not least, John.
John Suttie with Erland Construction, the field supervisor. My role here is I coordinate with sub-foreman on site, site safety, project details, quality, work to follow and advance the project schedule wherever feasible. I grew up a few miles from Erland's headquarters here in Burlington, and I now live in Wilmington, which is just one town over. I'm married, 4 children, 2 grandsons. I spend most of my time at home with family. I live in a family neighborhood, and that's just what we do.
Thanks, John. Thanks for letting us get to know you a little bit better. Now let's take that a step further. Mike, when you were a kid, what did you want to be when you grew up?
Oh my gosh, that's a surprise question. That one I wasn't prepared for, but I'm going to say I wanted to be like Bobby Orr. I wanted to be a professional hockey player. And I'm certainly enjoying the Bruins right now and hope they don't disappoint us as they normally do over the past few years. But we're rooting for them, and yeah, I'd love to be a professional hockey player.
Thanks, Mike. We have a couple people that have been on the podcast that also thought they were going to end up in that field as well, but didn't quite make it. But yeah, let's go Bees. We hope we get to the Stanley Cup. What about you, Vern?
Well, you guys steal my thunder. Growing up in Saskatchewan, of course, I wanted to play hockey in the NHL. Unfortunately, I was undersized and underskilled. So then I thought, maybe I should become a professional water skier. But growing up in Western Canada, the water was frozen 7 to 8 months of the year, so that didn't make it very far either.
Ben, since you've been on the podcast before, I'd like to switch up your question. Okay, what is your favorite movie of all time and why?
That one's easy. I'm not even sure I have to give the why. Braveheart, definitely my favorite movie of all times. Just a classic movie.
And back to Ted, what did you want to be when you grew up?
Well, I honestly can't remember that far back, but I always liked science fiction and outer space, so probably I wanted to be an astronaut way back then.
We've gotten that one too. A lot of people go the space route. And what about you, John?
When I was young, my grandfather was kind of the center of our family, and he was a carpenter. So I kind of grew up idolizing him and wanted to be a carpenter. That drove me to enroll in a local trade school. I was out on co-op by junior year, and never look back. One of the best decisions I made in my life.
That's awesome. Love hearing these stories. I know as a kid, I always had gone back and forth between different occupations. It's fun to see where our paths actually led us. All right, let's jump into today's discussion. I'm now going to hand over the mic to Ben to moderate.
First, I want to say thank you to Mike and Vern for joining us today. Great to have you guys with us. So we'll jump right into it. First question for Ted and John here. Why don't you guys kind of give us a little bit about the project that we'll be talking about today?
All right, this project is a 3-story steel and concrete frame shell and core building with 1 level of below-grade parking. The first floor elevation is 21.5 feet. The garage elevation is 11 feet, and the bottom of the excavation was 6.5 feet. Those numbers will become important a little later on. We had sheet piles driven around the perimeter of the garage to allow for the excavation, and the dewatering system was originally designed for 200 gallons per minute. In late December of 2021, we were excavating in the northwest corner and had a few thousand square feet down to subgrade at 6.5 feet exposed. They were walking around down there on firm, dry peat.
So John, just kind of following up on what Ted was talking about there, what were some of the challenges we encountered out on the site?
Well, we took down 2 existing properties for this project. One of the buildings didn't have very clear as-built. We discovered we suspected there'd be wood piles under there, and there certainly were. We also discovered some really large concrete grade beams under there. And as Ted stated, as we started excavating down, we encountered groundwater where we anticipated we would. We came in after a long weekend, about right after, I think, New Year's, and we had water in the hole, which was not much of a shock. And playing around with pumping and whatnot, we started to overwhelm the dewatering system on site, and we applied to upgrade that system. So the system we had in place was set up for 200 gallons a minute. We upgraded that by permit to flow 400 gallons a minute. That, in fact, we discovered we were not able to drop the water level. So we started putting together a larger dewatering system capable of handling an additional 1,000 gallons a minute. In the meantime, Mike's team at Haley Aldrich started investigating what was going on and taking a look at the ground conditions and where this volume of water was coming from.
Were there any interesting challenges related to safety and components to having the water on site?
Well, there was. So we were, not near the coast, so we quickly had a pond on site. So we had to consider life safety and have lifesavers and things like that, and rescue ropes if someone was, God forbid, to fall in. So that was some of the challenges there.
Great.
At that end where the water was up, it was at elevation 15 feet. So I said we were down at 6.5. So we had roughly 8.5 feet of water in the north end of the site.
So Mike, this question's for you. Explain from a geotechnical standpoint what led to the excess amount of groundwater.
It's interesting to hear everybody kind of rehash what we've gone through over the past year, right? And so to be here talking about it in the way we are, I'm happy to do it in that fashion. So certainly the outcome could have been different, and we might have been talking about something that didn't go well, but ultimately I'm still hopeful that this is all going to come out great. Having said that, and at a very high level, as Ted mentioned, this excavation, if you can imagine in plan view about, a football field, and the northern half of the football field is, I think, the area that was really the problematic area where we had a lot of water come in on us. And as Ted mentioned, we had put in what's called a sheet pile system or cofferdam around the excavation to hold the earth back, but also to help keep the water out. And when you think about the ground conditions at the site, in a lot of cases for a lot of projects, the soil materials below ground surface are sort of layered, where you might have sands over clays, over silts, over gravel, over bedrock. And that was generally how this site was, except for the fact that there were what we call veins of very coarse gravels that were finding their way through those different layers and making their way into our excavation, not just from around the sheeting, but also from below the bottom of the excavation. And as we got closer and closer in the excavation to those veins, there was lots of water in those gravels that wanted to be released. So once we tapped into those veins, the excavation, which no longer had soil in it, as Ted mentioned at one end, was down to about 10 or 12 feet below ground surface, quickly filled with water like a tub, and tried to equilibrate with the water level outside the sheeting, which was up around that 15 that Ted mentioned. So basically what happened is all the water came in from beneath, and there was so much water from the standpoint of pumping, it was not possible to keep up with the water coming into the excavation. So that's really the condition that presented itself just about a year ago, for which we got to become introduced to Vern, so to speak, very quickly.
Great. So I think it'd probably be good for the listeners for us to back up and kind of give them an overview of what our roles are. Ted, you want to kind of give us an overview of what Erland's role was on this?
So Erland is the construction manager, managing and building the project. We hired all the subcontractors who do all the actual work. And again, we were in the process of trying to excavate for the parking garage when all of this happened.
And Mike, you want to kind of give us an overview of what Haley Aldrich's role was on this project?
Sure. So we were the owner's geotechnical engineer. We were involved right from the beginning in terms of the process of which we work with the team for permitting, design, and then construction award. We were involved with doing test borings on the site prior to the buildings coming down, and then in the course of once the buildings went down, doing some more explorations to help better understand the subsurface conditions. We were involved with designing and making recommendations for foundations for the new building, involved with the recommendations for what to use for earth support and the dewatering components of the project. So we were out there representing the owner and observing the conditions right from the beginning in terms of the site work that started with the sheeting installation and the pile installation, and then transitioned into the excavation for the garage to the point where, as Ted mentioned, early January of last year when we encountered the conditions that we did at that northwest corner, so to speak.
And as you mentioned, Mike, we had the benefit of getting introduced to Vern. It really helped us out with this issue. If you want to give us a little overview of what your role was, Vern.
Yeah, absolutely. Keller was brought on as a specialty contractor, involved in these foundation issues. And our job was to come up with a solution along with the project team to try to come up with something that would stop this water from coming up from these veins or fingers of the geology. And so we were hired on site to perform the ultimate permeation grouting that was done in order to create this leaky bottom seal, as we called it.
So I remember the amount of meetings we had and between us and Keller and Haley Aldrich and the owner. Why don't you guys walk us through kind of what the process was for evaluating the issue?
Even before we brought Vern into the picture, right, we did a bit of sort of sleuthing and investigating with the site work contractor to try and really get a sense of what we thought the inflow of water was and whether or not it was a local condition or whether it was widespread. And the early indications were that, this was a situation that was not measurable at the time in terms of the volume of water. We didn't have the capacity to pump it and figure out actually the volume of water that we would need to be able to pump at to get the hole dewatered. At that point, that was when we felt we needed to, bring in a specialty contractor like Keller, who's got both experience with not just dewatering, but with permeation grouting and other grouting techniques to help be able to come up with a program that could solve this problem. So we brought Keller in with knowing from past experience their expertise on this. And, Vern and his team, once they were brought to the table and understood the conditions, they were very good at throwing out, different options to consider. And I'll just let him talk to those different options and ultimately how we landed on the option that was selected by the team and the ownership.
Yeah. When we started looking at this issue, we had quite a few soil borings to look at. We started looking at how the excavation and how it was affecting the job site, determining the geology and how it crossed the project site. We had a deep boring done at HA number 1, which gave us some water test values and material deposits. And then on top of that, we had some historical literature that determined some deep connections to water-bearing soils in the area. And through those, it came pretty apparent the type of a struggling geology that we had here. And so when we started looking at it, we thought, well, maybe we could do some jet grouting. Jet grouting is a process where you use high pressure to mix cement and soils together in order to create a stronger soil material or stronger foundation, and with that, quite a bit less permeability. But the problem here was that we had some existing foundations and piles and timbers and things like that, which would create some shadows effects, which would mean areas that would possibly be not treated and still allow a lot of water up through. We looked at doing maybe some soil mixing, and we had the same problems as above. And as well as that, we had some drilled displacement piles that were already installed. So we had to come up with a method that would not damage these drilled displacement piles. We looked at the dewatering and just going with more dewatering, but the project site was only allowed to discharge, I believe, 500 gallons per minute. And due to that, we could not go to the dewatering issue as they'd already determined.
Great, thank you. Mike, what kind of led to the project proceeding with permeation grouting and your recommendation or the team's recommendation to kind of move forward with that?
Well, I think ultimately on the table presented to the ownership was a series of about 3 or 4 options. And as you can imagine, with each option, there comes a level of sort of certainty or confidence, a pricing component with each, and a schedule component for each. And so of the 4 options that I think ultimately got whittled down to what we call a leaky bottom seal option, which involved sort of drilling and installing pipes. And one approach to that option was simply to just put the pipes in the ground, have slots in the pipes, and let some grout kind of work its way through gravity out into the formation. A slight modification to that was to install those pipes, do that same approach of letting the grout kind of go out by gravity, but actually installing TAM pipes, which are the permeation grouting pipes, tube and manchette pipes that would allow for controlled grouting within a particular zone. And then as Vern mentioned, we looked at the jet grouting option as one, which would have been around the perimeter of the excavation. And then finally, I think it was a similar perimeter approach, but with the permeation grouting. And I think those were the 4 options that as a team we kind of focused on and presented to the ownership. And as I said, they had various options, various levels of probability of success, cost, and schedule. And at the end of the day, the leaky bottom solution was the one selected by the team. It was not necessarily the most costly. It was not necessarily the one with the most probability of success. But it was the one that the team and the ownership were willing to go forward with and implement. And so that was what was selected. I think ultimately it was the right choice because we are where we are, but it took a long time to get there in terms of being able to make everything work coordination wise. And maybe you guys can actually talk to that, because from the standpoint of the coordination and the orchestrating of all the different trades, that was really where your expertise came in play. And you may even talk to the fact that while the work to make things better in the north half of the site was ongoing in its own sort of project, that you guys were able to also allow for the project to continue on a path towards being constructed on the south half of the site, which is, very, very impressive.
Yeah, I think that's a great point. I think the what we left out on the initial part of this was the fact that we didn't have the issues on half the site. This issue only really occurred on one half of the site, which was very, interesting as we were going, through it. And I think, going back to that selection process, I feel like there wasn't one option that checked every single box. Each option came with its own challenges. And I felt like the team really worked well to select the right option. And obviously we made the right choice as a group because of where we are right now. On that note, I was, from the Erland team, is there anything that you guys can think of, throughout that process that was challenges or, in selecting it and what we kind of saw as we were headed towards making that final decision?
I don't know if there was any challenges is the right word, and there was some frustration there that in order to accommodate what Vern's group had to do, we had to go and fill the north end back in with a lot of soil we had already taken out, so it was kind of a step backwards. But Mike came up with a wall and kind of in between the two ends, and it was like he said, it was very interesting being able to continue all the work in the south, and literally we were pumping 50 to 60 gallons per minute out of the south and kept working the whole time everything was happening in the north with just who knows how much water we had up there.
Great. So Vern, just for the listeners, if you could kind of give us an overview of what permeation grouting is, kind of explain the process, maybe even give some of the things we saw out there that might have been unique to the site.
Sure. Of course, this is one of my passions. I've been doing it for so long, and permeation grouting really is interesting stuff. But permeation grouting is the process of filling pore spaces between gravels, sands, and silts with a binder of some kind. These materials could be cementitious or a solution, non-particular type grout. In this case, the decision was made to use an economical solution using a grout mix composed of water, cement, bentonite, and superplasticizer. The mixed materials were added to a shear-style mixer that homogenized the mix into a thin chocolate milk type consistency. The mix was then pumped to the injection locations using a Moino-style pump. This pump doesn't work like a piston pump. It has fewer peaks and valleys. It gives you a much smoother pump curve so that you don't frack the soil, but you allow the materials to be pumped under a discrete pressure. We access the formation by drilling, utilizing a sonic drill overburden casing system. That sonic drill imparts a very high frequency to the drill steel and allows you to drill with very little mess. What was also nice about using the sonic drill overburden system was that we were able to bring up samples of the soils from all of these grout holes that we were going to be using. The sonic drill drills a 5-inch diameter hole casing, and inside of that we have a 4-inch, like a sampling tube, and we were able to bring these out and look at the materials as we place these pipes on 21-foot centers grid pattern. Once we did that, we installed a TAM pipe, which we talked about previously, a 2-inch sleeved PVC pipe. This sleeve the pipe is basically PVC with holes drilled every 16 inches along the length of it. And then those holes are covered with like a rubber sleeve that allows material to be pumped out through the holes, but does not allow material back into the pipe afterwards. So it works like a one-way valve and allows you to get grout into the formation. Here we used a really weak casing grout to seal the TAM pipes in and stop the injection material from coming back up to the surface through the annular space left over once the dams were involved. The pipes were installed to a depth up to about 68 feet on this 21-foot grid pattern, and we were able to then pump cement grouts very discreetly into the areas of concern of where we thought the water was coming from. And it pretty soon became apparent where our problems were. And once getting a material into the formation, we were able to look through a series of diagrams and some plots that were drawn up in order to see which areas were taking lots of grout which areas did not take as much grout. And so concentrate on the areas where the water was permeating up from. So that was another good portion about permeation grouting, that it allows for the discrete placement of the injection materials. The nice thing about the sonic drilling was that there was a limited amount of waste produced in the process, so you didn't have a big mess being made in the installation of the TAM pipes. And then we were able to specifically design the grout mix and access the formation for that material. Worked really well here.
Yeah, I just want to expand a little bit on that, because I think you hit on one of the other items we're going to talk about is some of those challenges. I think as we saw some of those bigger grout takes, we really, it took the team to really evaluate that and where we were going to, add additional TAMs and where we're going to attack some of those areas that were maybe producing more water, just so that we could have more of a comfort level when we did excavate. I don't know if you want to talk through, maybe Mike, I know you had your charts and graphs going throughout the process. I don't know if you want to kind of talk through that and maybe how the team worked through that, to identify where maybe some of those problem areas were.
I still have those on my wall, Mike.
They have wallpaper in the conference room.
Yeah, well, it would have been nice to maybe invite one more person to this call, and that would have been Cody, right? We wouldn't be here today without Cody, who, was out in the field controlling the whole operation for Keller. And he did a phenomenal job and taught me a new thing in terms of how to plot circles or bubbles on a spreadsheet. So that's the evolution of the bubble charts that we developed with elevation for each of the holes that helped us visually kind of see the introduction of the grout into the formations that we drilled through. And as Vern said, we had, good information recovered from the sonic drilling of the installation of the TAM pipes to help us at least visually get a sense of where we thought these open work gravels were that were going to take a lot of grout, and being able to correlate that with the actual injection points within the TAM pipes as to where the grout went was very useful in helping us figure out if we were doing what we were supposed to be doing. And as a sort of normal course of operation on these projects, right, the original plan is never, 100% correct. And so to your point, what we learned from the gridded layout that we started with and the information we gathered from the installation of the TAMs and the grouting, we were able to identify areas that still needed more grout, that we needed to tighten up the spacing of the TAM pipes, put some more TAM pipes in, put some more grout in, do different elevations of grouting, and work our way through to basically, reduce that volume of water where it was anticipated to kind of still be a problem once we started excavating again. And I don't know if this is maybe a good point, Ben, to talk to how we ultimately could put a number to the improvement in terms of, the volume of water that we ultimately ended up getting to. That was always a goal of the program, right? We really didn't know what we were starting with in terms of how many GPM we had to pump. So that was a big mystery. Nobody knew that. But the ultimate goal in the design, as Vern said, was to get to something that we could consistently not have to pump more than about 500 GPM, because we felt for a bunch of reasons that could be manageable, whether it be the dewatering system, the treatment system, the permitted discharge being allowed by the city and the other authorities. There was a lot of things playing into, why 500 GPM. And so the only way we could really understand how successful we were doing was to actually incrementally stop the grouting and allow the water to try and recover. And basically, while it's recovering, to perform some pump tests within the excavation. And, that was a little unnerving at first because we were trying to install grout and keep that activity going, but you had to pause every now and then. And I think we did it maybe once a month over the first few months to try and see how incrementally we were improving upon that reduction in the volume of water. And it was very critical to the program. And it was also very telling in terms of how successful we were becoming. And I think while we may never know what the original number was, we worked our way down to close to the 500 GPM. We never quite got to 500 GPM. And I think even today, 4 or 5 months after we stopped the grouting, we've kind of maintained somewhere around that 600 GPM range. We never could get below the 500, which, hasn't hurt us. It was a goal, a good goal to have. And I think, I'm going to say that we accomplished it, even though we're 500 GPM plus or minus 100 GPM. Kudos to Keller for getting us there.
Yeah, that's a great point. I almost forgot about those pump test weekends. That's actually a good topic for John. I don't know if you want to kind of run the listeners through what a pump test would look like from the standpoint of, when Keller might stop pumping or doing permeation grouting, to what the pump test looked like on the weekend, and then kind of how we gave the data or how Haley and Aldrich collected the data.
Yeah. So we couldn't be pumping water while they were grouting, because we'd be washing the grout away from the tailpipes and basically taking away from the effect of Vern's work. So if we were going to be doing a pump test on a Saturday, there was an agreement that grouting would start to wind down about noontime on that Friday to give that grout a good 12 hours overnight to cure, if you would. We'd take it from a test pit that was already in place. We would then fire the pumps up late in the morning, and I think we were capable of about 400 gallons a minute from one of those test pits, and we'd let it run for 4 or 6 hours, depending on Mike's team's suggestions that day, because everybody was there to witness these. And then basically we would wait to see how long it took for the water to come back into that test pit. They would time that.
Great. I don't know if you want to also kind of run the listeners through, what the process we went through, right? So we've gone through, Vernon and the permeation grouting. What were kind of the steps as we got through that process? What other subcontractors were involved? And Ted mentioned earlier that we had to fill the hole back in and create that platform. What were kind of other steps that we went through?
Yeah. So once the decision was made to move forward with the permeation grouting, W.R. French, who was still on site as the excavation contractor, they had to haul dense grade back in to build a stable working platform above the water table for Keller to bring their drill platform in. And W.R. French then stayed on site to support their operation, managing spoils and whatever they needed. At that point, Keller did come in with their sonic drill rig to install their TAM pipes, brought in the grout plant, which was an assembly in itself. It took up the whole north entry road, which was the kind of blocked off that half of the site, and began their grouting process, which was lots of grout being brought on site, mixed, lots of materials. Haley Aldrich was present on site every day, as mentioned by Vern. The cores that were brought up through the sonic drill rig, Mike's team was constantly assessing what came out of the hole. Lots of conversations going on about what was the next step, what they were seeing, anticipating hot spots, so what we thought would be the next high volume of grouts. There were some grout takes in certain TAM pipes that were kind of astonishing to me.
Yeah, I wanted to give Keller a lot of credit. I know that even there were some times there where we saw some material shortages on cement on our other projects, and we didn't miss a day out there, with the amount of cement we needed for this project. So, huge kudos to you guys to manage that process and keep us on track. So just wanted to run through and, kind of as we maybe start to wrap up here, discuss the end result, permeation grouting, the successful outcome. We're putting steel up as we speak, and the building's moving forward. So just wanted to throw it out and get people's take.
I can say that for the better part of a year, there haven't been many nights that haven't been sleepless thinking about this project, and particularly from end of December last year till about end of July this year. I still remember sort of my last weekly call with you guys with the updates on the grouting and feeling like I could finally go on a vacation and get away. It was a great relief, and it was only possible because, the team that was put together for the project was able to come together to come up with, a solution for a completely unexpected condition. So that's my take on it. I know we still have a ways to go and some sort of boxes to still check to say we're 100% there. But certainly, the path there, while it was long and winding, I think that we're close. And so, it's a testament to Erland, French, Keller, everyone, LRT. It was just a great come together under some difficult conditions.
I definitely back you up on that, Mike. The site team doing this work was put up with a lot of challenges and a lot of changes, and that would typically cause a lot of stress on a job site and cause a lot of tempers and that did not happen here. For the most part, this job was smooth, well organized, really good planning and cooperation between all the contractors and the site personnel and the owner. We had a lot of changes. Every time we turned around, we were changing something, and everybody smoothly adapted to it. And I must, definitely give kudos out to the team on that. That was a really good job.
Yeah, and I'd like to add again, Mike mentioned Cody, but Cody made all the difference in the world. He was very knowledgeable, very easy to get along with. When the owners or anyone came out to the site, he could explain what was going on and what was happening in layman's terms so they understood it. And to follow up on Vern's comment that we were all under the gun, but everybody got along. Everyone worked together. We knew we had a goal, because if we didn't succeed, we probably weren't going to build a building. So it was great. Everyone did work together. Everyone got along. Vern's group out there was incredible and great to work with. Mike's group was there every single day and asking questions and keeping everyone in the loop. So it was good. And Mike put a little plug in for LRT, but that's the dewatering sub for French, and they had their hands full as well. So everyone did a great job. It was interesting and very unique.
I couldn't have said that better myself. And, I got to thank you, Mike, for really giving me a crash course in geology and helping me understand what was going on the ground there. As a career carpenter, I know about nails and lumber and construction and vertical loads and all that, but that was not my thing. And you were very good at explaining to us how things were going on, and your team as well, Vern. That was a big help. And, it was a constant conversation in sight from, French's laborers to the operators. Everybody was kind of working towards the same goal. And it was, as tough as it was all good to see. It was a great outcome.
Yeah, I think just want to reiterate that. I think it was a huge team effort. I'm a big sports guy. I know we talked about hockey earlier. I'm more of a soccer guy. But, I think, the whole team, this is probably one of the biggest challenges I've seen on a project that I've been on, and probably one of the best teams I've seen, really solving problems as they occurred and keep moving forward.
Well, it's been great having you all on this month's podcast. Thank you for sitting down with me.
Thanks for having us.
Thank you for the invite.
Thank you all, and I'll be sure to tell Cody all of the good thoughts we all brought to him, because he'll appreciate it.
All right. Now, can you tell the listeners the best way to connect with you if they have any additional questions regarding this topic? We'll start with Ted.
You can reach me at tnevells@erland.com, or if you're out at the site, come on into the trailer. And like I said, I do have some very interesting charts and graphs on the wall of our journey. So please stop by.
And as Mike mentioned, it was kind of nice for us to all sit together and talk about this and look back on it. And it's bringing back a lot of things. If anybody has wants any further comments from me, I can be reached at jsuttie@erland.com. And as Ted also said, come on in the trailer and we can have a talk. And
Ben, go ahead.
Yeah, you can reach me on LinkedIn.
And then Mike, can I tell the listeners the best way to connect with you?
Sure. It would be Atwood@HaleyAldrich.com.
And then Vern, go ahead.
Yeah, Vernon.Frier@Keller-NA.com.
That's it for today's Tried and Blue. We hope you can join us next time for another exciting sit down with other Erland team members and maybe even some special guests. Keep checking our website to tune in.